All right, today we are going to talk about section 3.3. But before we get to that, we have some warm-up problems to do, just to review those characteristics of functions. So you try them first, and then you can push play and check. I'm going to, oops. And let's see. Oh. We'll do green and yellow. So this one is all positive. It's all above the, oh, I'm going to back up there. Actually, here's the warm-up. So we'll go positive, negative. So the positive part is just here above the x-axis. The negative parts are the parts below the x-axis. Remember, increasing and decreasing is riding that roller coaster from left to right. So here we are increasing, and then we decreasing. End behavior. End behavior is what's going on. So as we go to the left, as x gets smaller and smaller and smaller, what's happening? Well, this is getting smaller, and y values are getting smaller and smaller. As we look to the right, as we go to the right, it's also getting smaller and smaller and smaller. So there we go. Okay, here we've got our positive, negative. I might as well do increasing and decreasing. All right, so positive, the part above the x-axis, just that. Negative, the part below the x-axis. Increasing, oh, it's all increasing. We're only going up. End behavior, as we go left, y is going down. As we go to the right, y is going up, positive infinity. All right, so today we are talking about linear functions. Now notice in the word linear is the word line, and that's what we have to remember. So we defined what a function was. One input, one output, vertical line test with graphs, and so forth. But today we're talking about linear functions, so more specifically. And linear functions, the graph is a line. Also, when we look at the equation, it will look something like this. That is, it has plain old x and plain old y. No x squared, no square root of x, no x in a denominator, but just x and y, so that if we wanted to, we could rearrange it to look like this. So today, a lot of the problems are just going to be, is it linear or nonlinear? And that's what we're looking for. It's just, that's it. You don't have to explain even on the homework. So is the graph a line, a straight line? No. So this is non-linear. This one here, it is a straight line, so it is linear. That's it. With, when we have a table of values, we haven't done a lot of this yet, but you'll see on the example we do later. But to go from one point to the next, notice you go up 2 over 1. And then to go to the next point, up 2 over 1. So there's like every time x is increasing by 1, y is increasing by 2. So there's a constant increase or decrease, addition or subtraction. So what we're going to look at here is, we're going to do the second one first. As x increases by 3 each time, it looks like y is going down by 6 each time. So as long as those numbers are the same, in other words, all plus 3, and then on the bottom, all minus 6, then it is linear. That's what we're looking for. Up above, we can see plus 2.5, plus 2.5, plus 2.5, but down below it's plus 7, plus 11, plus 15, not constant. So this is non-linear. Earlier we talked about the equations. If it's plain old x and plain old y, then it's linear. Oh, actually, this one, the question is it a linear function? Yes. No, because that x squared, right? No, 3 to the x, that doesn't work. No x squared. This is yes. Even though it looks like a fraction, we could rewrite this so that it was 3/5 x. That's good. Again, it's plain old x. It's in the numerator, not the denominator. And this last one is yes, because like if we were going to graph this, if we called that 5 and graphed it, that's what it would look like. So it is a straight line. It would pass the vertical line test. All good. All right, so pause the tape. You try these now, and then push play, and we'll go over them. So this is linear, nice straight line, non-linear. So even though it's 2 straight lines, it's 2, not 1 straight line. These plus 1, plus 1, plus 1. This is plus 2, plus 2, plus 2. Yes. Oh, plus linear. Here, this is plus 1/16. This is plus 1/8. It's not the same. Non-linear. You might look at this one and say, oh, it's times 2, times 2, times 2, but that doesn't work. It has to be plus or minus the same amount each time. We're going to skip number 5. And then number 6, is it a linear function? Sorry, my iPad's ready to die, and I have to plug it in right now. All right, all set. So, not going to do number 5, but this is linear. This is linear. And this is non-linear because of that x squared. The last thing we're going to talk about is discrete and continuous. So discrete domain, remember, are your inputs. Discrete is when it can only be certain numbers or whole numbers. When we started this section, remember, some of the graphs were just points and some of the graphs were connected or had lines. And so this is like a discrete domain would be like, let's say we were selling, it's the Mercy raffle tickets. And, if our domain represented how many tickets we were selling, well, that would be discrete because we can only sell whole number tickets. We can't sell 2.5 tickets or 1.75 tickets, but they have to be whole numbers. So that would be discrete. Continuous would be if I was like filling up a bathtub with water, that water is pouring in at a continuous rate, or if like my domain was time, time is continuous. So those, then it's, we would have a line. So our example here is the linear function y equals 6x represents the cost y of x hot and ready pizzas from Little Caesars. Find the domain of the function. Is it continuous or discrete? So x refers to pizzas, how many pizzas we're going to buy, and y is the cost. So each hot ready pizza is $6. Can we buy 2.5 pizzas or 1.75 pizzas? No, they have to be whole numbers. So it is discrete. Can we buy -4 pizzas? No. We can buy 0 pizzas, and then otherwise we can purchase 1, 2, 3, 4, and so on. We'll just fill in the chart there. So our y values are going to be 6 times our x values. So 0 pizzas cost $0. 1 pizza costs $6. 2 pizzas cost $12. And they're going to go up by $6 each time. Now, to graph this, we're going to put on our x-axis, remember, input is pizzas. How many pizzas? So 0, 1, 2, 3, 4. and my y value is going to be cost in dollars. Now with 24, it looks like if we go by threes, that would work nicely. So when we graph it now, 0 pizzas cost $0. 1 pizza costs 6. 2 pizzas cost 12. 3 pizzas cost 18. 4 pizzas cost 24. So even though we're not going to connect the dots because it's discrete, we could see that they do all line up, and we could predict, the next number based on that pattern. And just like I said before, you can see like, all these are up $6 over 1, up $6 over 1. They have that constant, $6 more each time we add a pizza. All right. So the next example is, it says this function here represents the water in a 20-gallon tub that is draining at a rate of 4 gallons per minute. So X refers to minutes. So right now the water is full, it's 20 gallons in the tub, and it's draining out 4 gallons a minute. So first of all, is it discrete or continuous? Well, that water doesn't just plop out all at once, but it goes out continuously. So it would be continuous. We also could put in like 2.5 minutes, or, we can use a decimal or fraction for minutes, and it would make sense. What our X cannot be, though, is negative. We can't go or talk about -2 minutes or something. That wouldn't make sense. We're no time travelers. So it could be 0 minutes, 1, 2, 3, 4 minutes. So when we plug into that formula, 20 minus 4 times 0 is 20. 20 minus 4 times 1, 16. 20 minus 4 times 2, 12. And then 8, 4, they go down by 4 each time. So now let's label our graph. So X refers to minutes. 0, 1, 2, 3, 4. And our Y represents how much water is in the tub. Oops. In gallons. All right, so if we're graphing this, oh, I gotta label my other x's. In this case, I think I can go by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18. Oh, just made it 20. All right, so 0 is 20, 1 is 16, 2 is 12, 3 is 8, 4 is 4. Now in this case, we are going to connect these points because it is continuous. We could look, we could get a value or an answer for like 1.5 minutes. We also can see right here, we can see that the tub's going to be empty at 5 minutes. So that could be a question. When will the tub be empty? And the answer is at 5 minutes, right? So there you go. That is it.